Yes, the outlet is required to be GFCI protected. Understanding ground fault circuit interrupter (GFCI) protection is crucial for electrical safety, particularly in areas prone to moisture like kitchens and bathrooms. GFCI outlets are designed to protect individuals from electrical shock by monitoring the current flowing in a circuit. If there's an imbalance, indicating a potential ground fault, the GFCI trips the circuit, cutting off the power almost instantly. This prevents dangerous electrical shocks. Now, to delve into the specifics of why the described dining room outlet needs GFCI protection, let's consider the relevant electrical codes and guidelines. The National Electrical Code, or NEC, sets the standard for safe electrical installations. Article 210.8 of the NEC addresses GFCI protection requirements. Specifically 210.8. It generally requires GFCI protection for receptacles installed in dwelling units in certain locations. These locations include bathrooms, garages, outdoors, crawl spaces, unfinished basements, kitchens, and areas within 6 feet of sinks or wet bars. The scenario you presented describes an outlet in a dining room, but its proximity to a kitchen sink triggers the GFCI requirement. Since the outlet is less than 6 feet from the kitchen sink, it falls under the NEC requirement for GFCI protection. The purpose of this rule is to mitigate the risk of electrical shock in areas where water is present. Water significantly increases the conductivity of electricity, making electrical shocks more likely and more dangerous. Even though the outlet is located in the dining room, the proximity to the sink creates a potentially hazardous environment. Furthermore, the height of the outlet above the floor is not a determining factor in this requirement. The code focuses on the distance from the water source, regardless of the outlet's vertical position. Whether the outlet is 14 inches off the floor or higher, the 6-foot rule still applies. To comply with the NEC, there are 2 primary ways to provide GFCI protection for this outlet. Firstly, you can install a GFCI receptacle directly at the outlet location. These receptacles have a test and reset button on the face and can be easily identified. The GFCI receptacle monitors the current flowing through it and trips if a ground fault is detected. Secondly, you can install a GFCI circuit breaker in the electrical panel that protects the circuit serving the outlet. This option provides GFCI protection to all outlets on that particular circuit. When choosing between these options, consider the convenience of resetting the GFCI. A GFCI receptacle allows for easy resetting at the outlet location, while a GFCI circuit breaker requires a trip to the electrical panel. Installing a GFCI outlet is generally straightforward. Firstly, turn off the power to the circuit at the breaker. Secondly, remove the existing outlet from the electrical box. Thirdly, identify the line, hot, and neutral wires. These are usually black, white, and green or bare copper, respectively. Fourthly, connect the wires to the corresponding terminals on the GFCI receptacle, ensuring a secure connection. Fifthly, carefully tuck the wires back into the electrical box and mount the GFCI receptacle. Sixthly, install the cover plate and restore power to the circuit. Always test the GFCI outlet by pressing the test button and verifying that it trips. If it doesn't trip, something is wired incorrectly and you should consult with a qualified electrician. When using a GFCI circuit breaker, the installation process is similar, but it takes place in the electrical panel. Firstly, turn off the main breaker to energize the entire panel. Secondly, remove the cover panel. Thirdly, identify the circuit you want to protect and remove the existing breaker. Fourthly, connect the wires to the corresponding terminals on the GFCI breaker, including the neutral pigtail, which is typically connected to the neutral bus bar. Fifthly, install the GFCI breaker in the panel and replace the cover panel. Sixthly, turn on the main breaker and the GFCI breaker and test the GFCI function. Remember, working with electricity can be dangerous. If you're not comfortable performing these installations yourself, it's best to hire a qualified electrician. They have the expertise and tools to ensure the installation is done safely and correctly. In addition to the NEC requirements, local codes may have additional regulations regarding GFCI protection. It's always a good idea to check with your local building department to ensure compliance with all applicable codes. Ignoring GFCI requirements can have serious consequences. Firstly, it increases the risk of electrical shock, which can cause serious injury or even death. Secondly, it can lead to code violations, which can result in fines and require costly corrections. Thirdly, it can invalidate your homeowner's insurance policy in the event of an electrical accident. Therefore, it's crucial to take GFCI protection seriously and ensure that all required outlets are properly protected. In summary, the dining room outlet in question requires GFCI protection due to its proximity to the kitchen sink. This requirement is based on the NEC guidelines for electrical safety in wet areas. You can provide GFCI protection by installing either a GFCI receptacle at the outlet location or a GFCI circuit breaker in the electrical panel. Always follow safety precautions and consult with a qualified electrician if you're not comfortable performing the installation yourself. By understanding and complying with GFCI requirements, you can significantly reduce the risk of electrical shock and ensure a safer environment. The NEC also addresses other areas requiring GFCI protection, so it's beneficial to familiarize yourself with the code's requirements for various locations in your home. Firstly, bathrooms always require GFCI protection for all receptacles. This is due to the high risk of water exposure in bathrooms. Secondly, garages also require GFCI protection for all receptacles. Garages often have wet floors and can be used for various tasks involving water or dampness. Thirdly, outdoor receptacles must have GFCI protection. Outdoor environments are exposed to rain, snow, and other sources of moisture. Fourthly, crawl spaces and unfinished basements also require GFCI protection. These areas are often damp and can have exposed wiring. Fifthly, kitchens are required to have GFCI protection for all receptacles serving countertop surfaces. This is because countertops are frequently used near sinks and other water sources. Also, any receptacles within 6 feet of a sink require GFCI protection, as was discussed. The intent of GFCI protection is to prevent accidental electrical shocks from happening in areas that have water. GFCIs provide essential protection from electrical hazards. Make sure you understand the requirements to protect yourself and others. You should always check the local code's requirements and any special local requirements. Consult with a professional if you are not sure and do not do any work that is outside your skill set.